Subscribe to Amcode and ring the notification bell to get the latest content.
So let's talk about what do I mean by the nodes and the relationship in detail. So let's say we have to build a graph for active fraud monitoring. So basically you want to detect any fraudulent activities from your application data. So basically in application data you can have an application table in RDBMS. So similarly we can have an application node here. So here we have the application node, and application will contain all the properties. So application can have like the application ID, then the created date, then the source system, and so on. So these are nothing but the properties which consist of a key value pair. So application ID will be the key and the value would be whatever the value of application ID. So this will be the application node, and also we can have like different nodes for fraud score, credit score, and so on. So there are like different vendors like Experian and Centrelink which will provide the fraud scores to detect the fraudulent activity of any user in their database. So this can have like a fraud score, this can have like a credit score, and also this application would belong to any applicant. So basically here we'll be having some applicant, and applicant can have their first name, their last name, as well as their DOB. So this is your applicant node. And also in applicant it can have like different PII information available. So this can have like the contact information, like their contact number. It can have like a location node, and also so it can have their social security number, or in India we can call it as a Aadhaar number. So let's say we have like this type of fraud monitoring graph. So here as you can see, all the nodes or all this circle nothing but represents the nodes in a property graph. So basically these are nothing but the nodes which contains all the property and data, but the connection between this node is nothing but the relationship. So as you can see, these are having the relationship, and this is a directed graph. So let's talk about the direction as well. So basically if you convert this figure into English, then you will able to understand how the relationship direction will be there. So basically application will have the fraud score and credit score, so that's why there will be the relationship going from application towards the fraud score as well as the credit score. So basically the direction would be from app to fraud, and similarly application can have an applicant. So that's why the direction will go there, and applicant has all this PII. So therefore these are the directed graph. So this is our directed graph, but here as you can see, this relationship can also have some meaning to able to read that graph very easily. So let's say application and applicant have like a has applicant relationship. So basically this could be like a has applicant. Also we have like applicant will be has location, right? So has location, has contact, has Aadhaar number, as well as application can have relationships going outwards to the fraud score. So has fraud score and has credit score. So basically this will be the relationship types, and the node labels would be like the application, applicant, all their PIIs, as well as fraud score and the credit score. So this will denote the labels in the node. So labels we can refer it to the table in the RDBMS. So if you have a schema for fraud monitoring, you will be having a different table for storing this fraud score, then credit score, then we have a different table for application data, then applicant data. So you cannot keep them all in a one table to improve the performance. So because having all the data in the single table can deteriorate the performance very largely. So that's why we will be having different tables. But in graph we can have all the different labels, and all the records and nodes are connected to each other to get the leverage. So for fraud monitoring, let's say if we have another applicant here, so this will be like the applicant 2. So this applicant 2, if it is sharing the same location, so let's say this also have the same location. So this is the location of applicant 2 which is same between this. So basically it is like a single node in your graph. So you can easily identify that information using the relationship as well, because both the application will be having a single location node with the different relationships. So this is how you can identify the fraudulent application when they come into your system. So if your data coming in the real time into your graph database, and you are going to process it efficiently due to this relationship property graph. So this is how the actual fraud monitoring system works under the hood. So I hope you understood how the graph works and how we can leverage graph databases to get hidden patterns, and many of the specific use cases are pretty much suitable for the graph database, like we talk about, which is nothing but a fraud monitoring system. So let's take a simple example of Apache PySpark and how we can implement and get the knowledge out of those graphs using the graphics library. So this is like a pretty simple script to implement the graphics using Apache PySpark. So basically here all you have to do is you have to just import the required packages, and also you have to install the graph frames using the pip install. So I hope you already know how to install all the packages in your environment, so I'm not going to go into any details. So here you have to initialize the Spark context first, because we need to create some RDDs and then convert them into our data frame. So basically, as we have seen in the previous chart, we will be having like a two tables, one consists of nodes and one consists of the relationships, and we can combine those using this graph frame function or a class present in the graph frames library. So as you can see, once we initialize our Spark context as well as the SQL context, so the SQL context is you can implement using the SQL context class present in the PySpark.sql. And here as you can see, we have to create some vertices. So we have just taken some sample data like of a 3 rows, and also use the map function to parallelize it and convert it into a RDD. So sc.parallelize is one technique to create RDD using like a input data. So basically we have like this Alice, Bob and Charlie records present, and also we will be having like the ID of those vertices. And also in the edges we are also having this ID as well as the relationships. So these edges are nothing but relationships in our graph. So as we can see, these edges will join two nodes together. So as you can see, we are having the join from 1 to 2, then we have 2 to 3 and 3 to 2. So these are like a directed graph, and the direction is from left to right, and the property and the relationship types are nothing but the friend, follow and follow. So one person will follow another person, one friend is having friend with another friend. So this is how this simple property graph is having. And also as you can see, we are having this create data frame. So as you can see, we can create data frame using this SQL context as well. We have seen the Spark method, so here we are using the SQL context instead of it. And also as you can see, we are just going to pass the vertices and the edges data frame inside the graph frame. It is so simple as that. If you already have the data frames having like this vertices and the edges, you can create like graph frame on top of it. So graph frame will basically have all the ontology of your graph database. So here as you can see, we can use different sorts of operations like in degrees as well as the filter operation on top of your graph frame now. So graph frame nothing but is an abstraction of representing the graph in Spark, in Apache PySpark. So basically here we can use the collect method to collect all the degrees. So get the in degree of each vertex, you can use this collect method. And also if you want to count the number of follow connections, so you can say that you can use that too. So we can use the filter operation of the graph edges to able to get that number. So this is very simple example, but you can experiment it on your own, and you can let me know in the comments if you have any confusion of understanding the graph databases and how we can work with them using PySpark.
So that's it for today. I'll see you in the next lecture.